Hello, everybody. My name is Josh Lee. My mentor is Dr. Garg from OU Aerospace and Mechanical Engineering. And the project that I did was testing the thermal conductivity of polymers. Okay, so I'm pretty sure you guys have already taken a chemistry class and you guys know what polymer is, but what a polymer is. But this is just like a review of what a polymer is. So polymers are long chains of similar units. They can be made out of either plastic or organic materials. Famous one you guys probably know is graphene. So some key aspects about polymers and why they're so useful is that one, they're very cheap. So when used in industry, right, compared to iron and aluminum and titanium and all sorts of other stuff, producing polymers is very, very cheap considered to making those materials. And polymers aren't as dense as these metal materials, which makes them lightweight and more applicable to aerospace engineering. They also require less energy to make because all you need is a chemical lab and some ingredients to create polymers, unlike metals where you need time to refine them, to mold them into shape. And lastly, polymers are corrosion resistant. So unlike iron, which can easily rust and maybe break down over time, polymers are they require like pretty much no maintenance. Alrighty. So my project was testing over the thermal conductivity of polymers, and a specific polymer that I used was a combination of polyethylene and graphene. So for this project, I used a vacuum chamber was already pre-built by the grad students, and I was going to use that. And also here's an IR camera that I would have used for the project. So the procedure, so everything begins in a chemical lab, although I wasn't able to go into the chemical lab and make stuff because that's not my level. I probably blow stuff up. But yeah, so grad students created samples that I would use. Yeah, here's polyethylene, here is graphene in the picture over here. And then this is what a sample would look like. And then after they made the sample, they would use this machine in the bottom right to stretch it out. I'll explain why stretching is really important to this whole process in a second. But after they'd stretch it, I would cut it out and make an apparatus of it. I don't have a picture of the apparatus, so I had to draw one on Microsoft Paint. Let me see if I can screen share Microsoft Paint. So here's what the apparatus look like. So this is the polymer. The polymer is usually really small. I'll cut it into like a really small rectangle, maybe about 2 centimeters by 5 centimeters long, or big and yeah, 2 centimeters by 5 centimeters long and wide. And after I cut the polymer out, I would cut a little middle section here, as you can see, out, and then wrap a thin wire through it, and then apply thermal paste in the middle. So the reason for cutting this hole in the middle was to ensure that the heat would spread evenly throughout the whole polymer. And then the wire was the way to conduct energy throughout the polymer. And since this wire was very small wires have big resistance, which in turn which release a lot of heat. And then the thermal putty was just to help conduct the heat. And lastly, the thermocouples were there I had to attach them in, and they were used to measure the temperature of the polymer. Let me go back to PowerPoint. Okay. So yeah, so about stretching, stretching is really important because when you make the polymer, they don't come in like perfectly aligned. When you initially make the polymer, they come out in like that picture below to the bottom left. They're all scrambled, everything just scrambled out. After you stretch it out, they become more even and allow heat to conduct easier. So an example of like a microscopic close-up. So before the graphene and the polyethylene, you can see are all bunched up together here, and then after it's stretched, it's pretty smooth. Okay, yeah. So for the testing, after I made the apparatus and I attached the thermocouples, I would put it in the vacuum that the grad students created, and then just pretty much heat it up, make sure everything was working. Use the IR camera as a secondary thing to measure the temperature, just in case the thermocouples weren't working. And the reason we used the vacuum chamber was because we had to ensure that no weird particles would go on would be present while we were heating the polymer to make sure our results were correct. Yeah, so applications for polymers can be, so for instance, aircraft. Polymers can be used in aircraft because they're very lightweight. There's no
Hey,
need for
Josh,
maintenance.
you may want to switch back to your PowerPoints.
Oh, wait, did I not? I thought I switched over. Wait,
Yeah, that's great.
wait, it's good?
Yeah, now it is.
Oh, okay, my bad. Did you guys see these pictures? Yeah, so okay, yeah. So before, yeah, so it's the stretching part. Before is all tangled up, and then after it's more aligned. And then this is the microscopic image of the sample that I used. And then, yeah, so applications, yeah, they can be used for a variety of things. I mean, plastic bags, for example, shampoo bottles. But for like more industrial means, aircrafts, that you can use it for aircrafts. They're extremely lightweight. They don't need maintenance. And also for pipes, because plastics are non-corrosive. And yeah. So wait, before I go into questions, I just wanted to let you guys know that due to the second semester where Dr. Garg had a lot of meetings and COVID-19, I wasn't able to get any results. So yeah, if you guys have any questions, please ask.
All right, thanks, Josh. Good job. Does anyone have any questions or comments? So, Josh, I'm just curious if if you were to follow up on this project, what do you think like the next step would be, or next experiment you would try?
With like, can you elaborate on that question more? Like,
Well, I mean, like if you were able to keep doing this, like if you hadn't had to stop in the middle, what would have been the next thing you would want to do?
oh, okay. So yeah, so the next thing I would have planned to do was actually start testing the polymer because I didn't get the chance to do that. I would have put it in the vacuum chamber and started heating it up and just doing tests and and graphing everything out. Yeah.
Okay. All right, great. Thank you very much.